Okay. So here we go. Factorial notation. Let's get that out of the way. I want you to know where that symbol is. The exclamation mark, that is factorial. Okay. I really dislike how they did this part. Like, to find that is like needle in the haystack, right? But anyways, you press math, you go to probability. So you got to go sideways all the way to probability, and that's where you see the exclamation mark. Which is, the nice thing is these calculators, let's say, for example, I want to know what 20 factorial is. So 20, then I would have to go math, probability, fourth option, right? So painful. Like, it should have just been one of the buttons, in my opinion, because it's used often enough. So let's say you do a calculation like that, and then you want to know, oh, what's 12 factorial? Instead of going and getting it, right, I would probably say, well, I'm just going to do this, right? Just copy, go get the latest factorial, right? Like, because it's just so time consuming. I really dislike that. If you find a shortcut, please let me know, because you are way more tech savvy than me. Like, I know you can find out, right? Like, Google it and then you find out. Please let me know. Anyways, so 6 exclamation mark, it's not saying 6, it's saying 6 factorial, okay? Which means 6 times 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times, right? And so forth. That's what factorial means. That's where you find it. So put it on your study sheet, maybe put this on your study sheet, because you might forget, a couple units down the road. So I will box that in, remember? Anything boxed in is important. In general, n factorial means the product of all natural numbers from 1 to n, such that, so in general, this is in general, n factorial means take n itself, then multiply it by 1 less than that, 1 less than that, 1 less than that, all the way until you get to 1. Okay? For various reasons, 0 factorial is equal to 1. Just memorize that or put it on your study sheet. Maybe that's worth highlighting. Oops, sorry, because it's going to come up from time to time. Right? Just remember that. You cannot take the factorial of negative numbers. Okay? You cannot take the factorial of negative numbers. If you try, or decimals for that matter, if you try, the calculator is going to complain. It's going to give you an error, so don't even try. The answer to such question is undefined. Okay? Undefined. If you ever take, if it's asking you, hey, what would the answer be to this? Undefined. Okay. So allow me to. It's going to be a little tedious, but I want you to expand. Okay. If you see that, this is, you expand, right? This is expanded, and that would be, if you went 6 times 5 times 4 in your calculator, you would get 720. However, let's try that. 6 factorial, right? 6, oh, I can just go and get a previous answer, right? And I'm just going to turn that into, I'm going to delete that, type in 6. 6 factorial is 720. There it is, okay? What about this one? Undefined. Okay, undefined, cannot take the factorial of a negative. What about this one? That one is actually okay, because there are no brackets around it. This is really saying negative 1 times 8 factorial. That's what that is saying. So basically, you would go like this. Leave the negative in front. Figure out what 8 factorial is. Okay, grab your calculator. I'm going to copy the previous. I think that makes it easier with this calculator to just go and copy. But the older ones, did you use the old ones last year? Yeah, those ones, I really dislike teaching this unit with those. So 40,320 is 8 factorial. And then you multiply, obviously it's going to be negative. So you just have to make sure that if the negative is like that, it's not included in the 8. So you would take 8 factorial then multiply by -1. There we go. 0 factorial, 1, right? And if you don't trust me, you try it. It's 1, right? What about something like this? This you have to be careful. I will make these numbers big enough that your calculator cannot even handle it quite often. So what you need to do here is this. It will transfer, okay? The bigger number is the one you break down. So this one here, I will go 8 times 7 times 6. I want to do this in your notes, so allow me to do this. It's going to be a bit more work, but I think you will understand. You need to understand that this part, if I were to cut this off, this would be 6 factorial, correct? Just this. So is this. And so basically you can cancel them out, right? So allow me to do this one more time. 8 times 7 times 6 factorial over 6 factorial. Let's compress it again. I'm just like, back to this. You can cancel that, correct? That's 1. This is really 1. Some teachers do not like saying cancels because it's really this divided by this is 1. Okay? So it's almost like 8 times 7 times 1, which is 56. Okay. Start with the largest, right? So I'll put a note there. Expand largest factorial. Like when I want you to simplify, right? Or what's the other word that we use? Evaluate. If you want to evaluate them, this is kind of, you could skip this step. You could go straight to here. And that's what I'm going to do moving forward. So watch. Right, so 7 factorial, obviously this is the bigger one. So 7 times 6 times 5 times 4 times 3. I'm not going to keep going. I'm just going to factorial it. Okay, over 3 factorial, and then this goes with that. And you're left with 7 times 6 times. Do I have that in my notes? It doesn't look like it. So I'm just going to go, what is this? This is 20. 120 times 7, that's 840. So we're going somewhere with this, trust me. 6 times 5 times 4 factorial over 4 factorial, cancel, that's 30, okay? And this one is the one, for example, that you couldn't do on your calculator. So let's try it. I'm going to go copy a factorial somewhere up here. Will this work? I don't know if I can insert, probably not. Can I insert like this? Yeah, okay. So I'm going to just delete that. And it's going to give you an overflow error. Can't do it. 100 factorial because it's 100 times 99 times 98, right? It's such a big number, it just can't handle it. So what we're going to do here, if you go to, it doesn't like that factorial, right? So we're just going to do what we know how to do, right? You pick the biggest number, it's this one. So we're going to go 100 times 99 times 98 times 97, and you're like, oh, that matches this one, so I'm just going to factorial it because I don't want to keep writing that down. Over 97 factorial, boom, boom, right? That one I have, that one is 9900. Okay, and soon enough this is going to be morphed into counting methods, like we're going to morph this into word problems. Okay. What about this one? This one here. So you have one with a factorial, one without. So keep this 4 out. Okay. So this would be 4 times. Can you do 3 factorial in your head? 6. It's 6. So 4 times 6 is 24. Okay. So in that case, it's just like that. Got it? So this is just basic warm-up to factorial. It's going to get interesting, trust me. It gets pretty crazy in a bit, but you can handle it. I'm just saying you're going to have to watch out. Okay. Looking at my time here. So what about, and there's a typo in this booklet. I already found it, so I'll tell you in a bit. That's what happens sometimes. So what about this? Oh, there's a lot of going on. These two are multiplying that. So I would still identify the largest one, which is this, and work with it. So 17, 16, 15, 14, I'll stop there because I recognize that there's a 14 factorial here. And when things multiply like this in the denominator, right, and in the numerator, if things are multiplying, yes, you can do that, no problem. Okay. And then I'm just going to go 17 times 16 times 15 over, we know that 3 factorial is 6, correct? 3 times 2 times 1. So that's just that. And then you go ahead and figure that out, and that is 680. You want to do, I don't know, I like every once in a while, you can simplify things and try to do mental math here. So this is one way of doing it, okay? I noticed that 3 goes in here how many times? 5 times. And 3 goes in here 2 times, right? So 3 is that common factor. You can keep simplifying. I see that these are both even. How many times does the 2 go into here? 8 times. The 2 goes into here 1 time. So it's really like in the denominator, you're down to 1. So it's really 17 times 8 times 5. And you're like, I just want to use my calculator. That's okay. That's fine. You're entitled to that. But if you want to learn something new, you might down the road have to be able to simplify. Then you do that, right? Here's another one. I'm just gonna leave that up to you. The answer is 220. If you want to practice, I'm giving you the answer there. 220. I want to get to the next part. That's the okay. Simplify expressions involving factorials. So that's basically this is what I want you to highlight. That's the main part for today, basically. When you have factorials involving variables, you want to try and cancel out certain expressions. To help you with this, I would suggest to expand the greater, right? Here's another thing worth highlighting. Expand the greater expression. And here's the typo in this sentence. You ready? Maybe I should do that from time to time to make sure you're awake. N plus 5 factorial is greater than n plus 1 factorial. Would you agree? Yeah, right. Like if n is 5, then this would be 10 factorial and this would be 6 factorial. Here's the typo. N minus 8 factorial is greater than n minus 4. That's not true. So how are we going to do this? I was just going to make this a 4. And I was going to make this an 8. So change that. That's important, or else you'll be like scratching your head when you're studying. Okay. There are certain values for which the expression is invalid. These restrictions need to be stated. Okay. So I will say restrictions need to be stated is worth highlighting. And here's another typo. If you have multiple values, the largest is the one stated. I made this from scratch, so I sometimes, there are mistakes, but I'll catch them. So the largest is the one that prevails overall. That's the one you want to deal with. Okay, simplify the following. State any restrictions. So you cannot have, by restrictions, okay, values of n so that, comma, so that there are no negative factorials. Like that's basically what I mean by that. You want to catch the values that are not permissible. So here we go. First, you look at this expression, okay? How would you simplify this? If I threw something like this at you, how would you simplify that? Do you notice that this one is just one less than that? Do you notice that? It's almost like saying this. Make sure you don't mix this up, but it's almost like saying, hey, 10 times 9 factorial, right? Wouldn't it just make sense to just say, well, I know that that's 10 factorial? Because this is 10 times 9 times 8 times 7. Does that make sense? So this is just simply n plus 5 factorial. Okay. So this is just an example to let you see that this is what's happening here. Like this is a number and then one less than it factorial. You can just bag them up, right? Like put them all in one bag and just say, hey, then it's the whole thing factorial. So that's as simple as that. I will state the restriction. N, and you need to go back to the original here. No. N has to be greater than or equal to -4. Okay. And why is that? Well, if n is equal to -4, then -4 plus 4 will be 0. 0 factorial is 1. But it cannot be less. Like if you had a -5, right, then it would be -5 plus 4 would be -1. You can't take factorials of negative. So you always got to look at, right, like what do I need to make sure happens so that I don't have any negatives, okay, negative factorials. Next, n factorial over n minus 2 factorial. I will state this. At the top, if you look at the top, n has to be greater than or equal to 0, right? And the bottom, n has to be greater than or equal to, it has to be 2 or greater, okay? And so basically, you will always take the largest of the two. Like this is the prevailing, because if this happens, you don't even have to worry about it going as low as 0, okay? So this is the largest, right? So that's the one you pick. And then you're safe. You're making sure that this will never be negative, okay? So here we go. Expand the largest. Which one of these two is the largest? N, right? N is bigger than n minus 2, correct? So that's the one you're going to expand. So watch this. A lot of students forget this. N is the first one. Like this thing comes first. Then the next one will be n minus 1. Right? It'll be one less. The next one will be n minus 2. And you're like, hey, I have that one here. So you stop expanding, just slap that factorial on there, and voila, right? You're good to go. You can cancel, because after that it would match, right? N minus 3, n minus 4, like they would just cancel out until you get to 1. Okay? And so you're left with n times n minus 1. And so, you remember expanding? IPR, we did a little bit of in grade 11 applied. So you just distribute. So that'd be n squared minus n. that would be considered um, a simplified expression. Fully simplified. Sorry, you can see that. Fully simplified. There you go. So I start with my restrictions first, then I worry about the rest. All right, keep going. This is exciting, guys. This is the nice thing about these ones. If you practice these, you get a break from all the other, like, how many combinations, right? If you see this, you're like, I know what to do, right? I know what to do. I just need to follow the steps, right? So let's go here. First thing is restrictions. State them right away. Don't wait, because a lot of students forget that. I can't give you full marks if you forget. At the top, you have n has to be greater than or equal to. Bottom, n has to be greater than or equal to. Like, that's almost a given. You have to figure out the values that has to be greater than or equal to. Here, what do I need it to be greater than or equal to? -2 is acceptable because that would turn this into 0. At the bottom, this would have to be 1 or greater, correct? Are you following? Yeah? Okay. Just checking. This is the greater one. This is the overall restriction. You don't need to worry about this because if n has to be greater than or equal to 1, you're never even going to go this low, right? So this must happen, because if this doesn't happen, you're toast already, right? Like, it has to be. So which one is the greater one? Top, right? So n, watch this, n plus 2, whatever is in here, that has to be the first expression. Then the next one is n plus 1, right? Because it's 1 less. What's the next one? N, right? Because n plus 2, you take 1 away from that, it's n plus 1. You take 1 away from that, you're just down to n. And then it's n minus 1. Oh, I stopped because I recognize that I see that at the bottom. Okay, ka-ching, right? Guillotine, cut that off, and then this is going to be a bit challenging here. I will not lie to you, but you can handle it. Okay, you can handle it. Do it one step at a time. Foil it. I'm going to forget about this n for now and just worry about this. So n times n is n squared. N times 1 is n. 2 times n is 2n. 2 times 1 is 2. All of that is still being multiplied by n that is outside. And then you just distribute. Actually, there's something that you should do before, because it just makes it a little bit less time consuming. N squared, these two combine to have how many n's? 3n positive, so watch the sign, plus 2, all of that multiplied by n. And now you distribute again, so you go, right? So I'm going to start here, n to the power of n squared times n cubed, plus 3n times n is 3n squared. Okay, when n's multiply, you actually add the exponents. There's an exponent of 1 here, exponent of 1, right? So 1 and 1 is 2. Plus 2 times n, if it's a number in a letter, then it's just slap them together like that. And this is your final expression. Three marks for something like this, including restrictions, including this expansion, distribution, all of that stuff. Give this a try. Let's do, I'm actually going to get you to do both. Use pencil. There's lots of room there. If you make a mistake, we can like squeeze in the right answer there somewhere. Okay, I'll do it with you, but I need you to get your feet wet a little bit. All right. So for the restrictions, let me clarify, maybe make it a little easier, right? So it's basically going to be the opposite sign of what is here, right? So at the top, it's actually n has to be greater than or equal to plus 2. And at the bottom, whatever is here, right, greater than or equal to negative 1. Right, you're saying negative 1 is the lowest that it can get because that gets you to 0, right? And then you can't get lower than that. So in this case, this is the greater, right? The greater restriction. So if you meet this criteria, everything else is not a problem, right? And then you need to expand the greater one of the two. Right? I'm going to expand that one. N plus 1, right? So you start with it. And then the next one would be n. And then the next one would be n minus 1. So you should be able to see that it's going down by 1 after every step. One more, n minus 2. And that's when I slap a factorial on there because I realize that I have my factorial at the top as well. So you've expanded it, you got here, you do this, you're actually left with 1 in the numerator. And this is, let's bring the n to the front. And then we're going to go n plus 1, n minus 1, like this. Because when numbers are multiplying, right, it doesn't matter. 10 times 5 times 4 or 4 times 10 times 5, you can move it around, no problem. And maybe I'll bring this over here. Okay, so that would be 1 over. I will distribute here. I put the n here, this one here. But this is n squared minus n. And then here it's plus n. Positive 1 times negative 1 is negative 1. Okay, clean it up a bit. N times, these two actually cancel out. Did you notice that? If you did expand, this is gone, right? So it's n squared minus 1. And this is my grand finale here. This would be n cubed minus n. This is where it's at, right? So you're like, what? How did the 1 come in there? Well, it's just like when you cancel, like let's say you have 5 times 4 over 4. When you cancel these out, it's not like it's 5 over 0, is it? Because that'd be undefined. Right? This is wrong. It's 5 over 1, right? It's 5 over 1. So when you cancel everything out, either top or bottom, there's a 1 left, okay? Because this is, when you cancel these out, it's actually 1, okay? That is actually turning into a 1, okay? Here we go. I think I'll leave this one for now. Homework, okay? You wanted that, didn't you? Here's the final, I'll give you the final product here. You're supposed to get, I'm going to do that way at the bottom of this page here. That would be n cubed plus 3n squared plus 2n. Okay, so there you have the answer if you want to give that a try at home. There's going to be some in the textbook as well, but these ones perhaps are a bit more challenging. Don't pack just yet. There's one more thing. You still have 7 minutes. I want at least 3 of those. Okay, so I just want this for you to do because I don't have time to go over that. Let's apply what we've learned in a slightly different way. Slightly different way. How can we use factorials now? You've seen factorials. We've done it a couple of times, right? It's like how many times can you do pre-cal, right? 6, 5, 4, 3, 2, 1, right? So same thing. So there's 16 billiard balls. What is the number of possible ways to pick 3 balls without replacing them? So using the fundamental counting principle, you would go 16 times 15 times 14, right? So write that down. That'd be 3,360 ways. Okay. What about factorial notation? How could you possibly do that using factorial notation? Well, you would say it starts with 16. I see a pattern that it's going down. So I would start with 16 factorial. But what do I need to divide this by? Like I don't, it doesn't go 13, 12, 11, correct? So I need to divide this by 13 factorial. Why, you may ask? Because 16 times 15 times 14 times 13 factorial over 13 factorial, this cancels out and then you're left with that, okay? Trust me, right now you just have to go with it. It's gonna become clearer how we use factorials in a bit. I'm gonna use a formula actually. One more here. There are 6 people running for president, vice president. How many possible combinations, assuming that the top 2 win the spots? So if there's president and vice president, obviously it's a limited supply, right? So 6 people you could pick for president, and then you would be left with 5. So that is 30 ways. Using factorial notation, you would go, well, I see that it's decreasing, so 6 factorial, but what am I going to divide this by? What is not here? 4, 3, 2, 1, correct? So you'd have to go like this. So this is 6 times 5 times 4 factorial over 4 factorial cancels out. So that's 30 ways. One more, and then we're done. Oh, I just added this. Okay. The volleyball team has 12 players and 2 coaches. I'd like to take pictures. How many ways can they be arranged if the coaches are to stand at the center? How does that work? This is grouping. So later. Sorry. I don't wanna confuse you right now with grouping. We'll just do later. This is your homework in the textbook. Thank you guys. Put grouping here. Put grouping. Because later you will know what that word means. Grouping, you're like, oh, that's why we didn't do it because we weren't ready. Okay.